and welcome to another video. In this video, we'll be talking about Thevenin's theorem, following up our series on DC circuit theory. Alright, what does Thevenin's theorem state? This law states that in any linear circuit containing several source voltage and resistor can be simplified to an equivalent Thevenin circuit having only one single voltage, a load resistor, and an equivalent resistance. Right? Mathematically, I Thevenin is equals to voltage, which is E or V, divided by RTH plus R, where E is the voltage source, RTH is the equivalent resistance, while R is the load resistor. The circuit diagram for Thevenin theorem. Circuit diagram. This is your I Thevenin. This is your load resistor. This is RTH, and this is your voltage source. Alright, meaning whenever you are given a question, you are given a circuit problem to analyze, your first task is to simplify that circuit to this diagram, to this circuit. This is the Thevenin circuit, and implement this formula. Then you are good to go. So that's all it is under Thevenin's theorem. Alright, let's solve this example using Thevenin's theorem. Find the current in 5 ohm resistor. We are told that we should find the current in the 5 ohm resistor. Okay? Mind you, our task is to convert this given circuit to Thevenin circuit. From the theorem, it states that in any linear circuit containing several voltage, we have 2 voltage, and resistors, we have 3 resistors. We have to simplify to an equivalent Thevenin circuit, which is this. How do you get the current in the 5 ohm resistor? This 5 ohm resistor is referred to as the load resistor, meaning in Thevenin's theorem, any resistor you are asked to find the current, it becomes the load resistor. Right? Now, having said that, I want to look for the current in this 5 ohm resistor using Thevenin's theorem. Meaning, applying Thevenin's equation, I Thevenin is equals to the voltage of this 5 ohms, right, divided by the total resistance of this circuit plus the load resistor, which is 5. Solution: short circuit the load resistor, meaning short circuit the resistor you are asked to calculate the current. By the time you short circuit, this will be your diagram, but you have to redraw the diagram. This is your diagram. Take note of this. In a parallel circuit, the voltage must be the same. Meaning, in this circuit, branch AD, branch BE, and branch CF must be equal. That is, knowing the value of branch AD and knowing the value of branch BE, automatically you obtain the value of voltage of branch CF, and we are done obtaining the value of the voltage of 5 ohm resistor, which is branch CF. Then how do you go about it? Observe, in branch AD, you are having 2 circuit elements. You are having a voltage and a resistor. Similarly, in branch BE, you are having a voltage and a resistor. How do you get the net voltage here, and how do you get the net voltage? What you need to do is to convert your resistor in branch AD to a voltage. Similarly, convert your resistor in branch BE to a voltage. Then, having done that, is either you subtract or you add, so as to get exact value in each branch. Let's see. But before then, recall from Ohm's law, V is equals to IR. V is equals to IR. So therefore, okay, call this equation 1. So therefore, I is equals to V over R. Call this equation 2. What it means is that to convert your 0.5 ohms to a voltage so as to obtain the net voltage in branch AD, you need the current of this 0.5 ohm resistor. Recall from Ohm's law, voltage is equals to I times R, current times resistor. Now, for 0.5 ohm resistor, V is equals to IR. The value of V, what is the current? The current is unknown, times 0.5 ohms. Then how do you get the current? Similarly, for branch BE, the current is unknown for 2 ohm resistor. Then how do you get the current? This is loop 1 and this is loop 2. For loop 1, current can flow through loop 1. This is a circuit. Current can flow through this circuit. While for loop 2, current can't flow through loop 2. Why? Because it is an open circuit. But this is a closed circuit, hence current can flow through it. Meaning, let's call the current flowing through loop 1 as I. That is, the value of current in 2 ohm resistor is I. Similarly, the same I is flowing through 0.5 ohm resistor. That is, the value of current in 0.5 ohm resistor is I, because it is a closed circuit. Whereas for loop 2, it is an open circuit, hence no current will flow. Meaning, to convert 0.5 ohm resistor to a voltage, you simply need to know the value of I, which is the current flowing through it. Similarly, to convert 2 ohm resistor to a voltage, you simply need to know the value of I, which is the current flowing through it. Then how do you get the value of I? Applying equation 2 for loop 1, applying equation 2, I is equals to V over R. For loop 1, we have 2 voltage sources, 4 volts and 12 volts. So therefore, to get the current in loop 1, sum voltage together, 4 plus 12, the value of resistance 0.5 and 2, and 0.5 plus 2. This is 16 divided by 2.5, and this is equal to 6.4 ohms. Meaning, for loop 1, the value of current flowing through loop 1 is 6.4 ampere. That is, 6.4 ampere is flowing through 2 ohm resistor, and 6.4 ampere is flowing through 0.5 ohm resistor. This is the current. It's going in this direction, 6.4 ampere. So to convert 2 ohms to voltage, simply multiply 2, which is the resistor, times the current flowing through it. Also, simply multiply 0.5 times the current flowing through it, which is 6.4 ampere. Alright, let's obtain that. For the voltage of 0.2 ohms, from Ohm's law, from equation 1, V is equals to IR. What is the value of current in 0.2 ohms? We have 6.4 times, what's the resistor itself? Sorry, this is 2 ohms. Times 2, what do you have? It's 12.8 volts. Also, the voltage of 0.5 ohms. Applying equation 1, what's the current flowing through 0.5 ohms? We have 6.4 times the resistor itself, that's 0.5, which is equals to 3.2 volts. Alright, let's redraw the circuit in terms of voltage. This is the circuit in terms of voltage and resistor. Since we've gotten the value of the voltage of 0.5 ohms and 2 ohms, let's redraw the circuit in terms of voltage. Redraw the circuit in terms of voltage. This is what we have. For branch AD, we've converted 0.05 ohms to voltage and the value is 3.2 volts. Similarly, 4 volts from the question. For branch BC, we have 12 volts from the question initially, then 2 ohms in terms of volts, we got 12.8 volts. So this is it. Alright, and we said earlier that the voltage in branch AD must be equal to the voltage in branch BE and must be equal to the voltage in branch CF. Meaning, knowing the value of voltage here. Okay, let's call this equation 1. Meaning from equation 1, the value of voltage in branch AD is equal to value of voltage in CF. Also, the value of voltage in branch BE is equal to the value of voltage in branch CF. So this is what it means. That's what equation 1 means. Okay? Alright, let's see if they are equal. In branch AD, by the time you subtracting 3.2 volts from 4, what do you have? From branch AD, we have 4 volts minus 3.2 volts. This is 0.8 volts. Branch BE, subtracting 12 from 12.8 volts. What do we have? That's 12.8 volts minus 12 volts, and this is equal to 0.8 volts. Hence, so therefore, 0.8 volts, which is the voltage of branch AD, is equal to 0.8 volts, which is equal to the voltage of branch BE, is equal to the voltage of branch CF, which is the unknown we are calculating from the question. So that's how it works. This is how you calculate the value of voltage of your load resistor. Alright, here's a nice question to ask. From here, how do you know whether to plus or to minus? In some cases, by the time you minus this, by the time you subtract branch AD, your branch BE, probably it might be addition, so as to get exact value. So it varies. Just confirm. Is it minus, is it subtraction that will give you the two values to be equal, or is it positive that will give you the two values to be equal? Whichever way it is, your one concentration, the two values must be equal. Why? Because in a parallel circuit, voltage are equal. So this is how we get the value of voltage in branch CF, which is the load resistor. Recall from Thevenin's theorem, we said that I Thevenin is equal to V divided by R Thevenin plus the load resistor. We've calculated the value of voltage to be 0.8 volts, right? Then we know our R load, which is the 5 ohm resistor. Then how do we get RTH? Solving for RTH, step 2. When you want to solve for RTH, what RTH means is that we are calculating the equivalent resistance in the circuit. From the question, this is the circuit. How do you get the equivalent resistance? Okay, from here, we just have two resistors, 0.5 ohm resistor and 2 ohm resistor. So we join the circuit. This is what you have. Don't mind you, not forgetting that you short-circuited this place. You don't have any circuit element present in branch CF. So let's solve the equivalent resistor. This resistor, they are in parallel. And for parallel connection, how do you get the equivalent resistance? You simply get the equivalent resistance by adding the reciprocal of the individual. Meaning, for branch AD, the reciprocal will be 1 divided by 0.5. Similarly, for branch CE, the reciprocal it will be 1 divided by 2, meaning your equivalent resistance is equals to 1 divided by 0.5 plus 1 divided by 2, right? Which is still the same thing as your equivalent resistance is equals to the product of the resistor divided by the sum of the resistors, meaning 2 times 0.5 divided by 2 plus 0.5, which gives me 1 divided by 2.5, and this is equals to 0.4 ohms. So therefore, RTH, which is your Thevenin, is equals to 0.4 ohms. Then you are done. Alright, let's recall Thevenin formula and substitute the respective value for E, which is the voltage source, for RTH, which is 0.4, and for the load resistor R, which is 5. Also drawing the Thevenin circuit diagram. Drawing the Thevenin equivalent circuit, recall, this is the Thevenin circuit diagram. So therefore, the Thevenin circuit diagram is equivalent to this. When we did our calculation for E, we got 0.8 volts, meaning the voltage of the load resistor. Then RTH, 0.4 ohms. Then the load resistor itself, we have 5 ohms. Now, what will be the value of the Thevenin, which is ITH, question mark? Recall, from Thevenin law, ITH is equals to E divided by RTH plus R. Substituting the respective value, it implies that what the value of E, 0.8, divided by RTH, now 0.4, plus your load resistor, 5. So therefore, ITH is equals to 0.8 divided by 2.4, and this is equals to 0.148 amperes, approximately 0.15 amperes. Then that's the end of that question. Let's relate what the theorem states to what we've done so far. The theorem states that in any linear circuit containing more than several source voltage and resistor, it can be resolved or simplified to an equivalent Thevenin circuit containing one source EMF, containing one source voltage, a resistor meaning the load resistor, and the Thevenin resistor. And that's what we've done so far. This is the given question. This question comprises of 2 voltage, which is the source voltage. We converted these 2 voltage into a source voltage, and we got 0.8 volts, right? We have 2 resistors in this case, 0.5 ohms and 2 ohms. We converted it to 0.4 ohms, right? Then the load resistor itself, and that's it. Then applying this formula, which is the Thevenin's formula, then we got our answer. Don't forget, your load resistor is the resistor you are calculating the value of the current. So that's what it means by Thevenin's theorem. If you find this video helpful, don't forget to share your thoughts in the comment section, subscribe, like, comment, and share to a friend to watch as well. To get more videos and examples on Thevenin's theorem, check the link below to access the video prepared for you. Alright, see you in the next class.